Okay, so today we are going to start with number patterns. This is the fourth topic, number patterns. Okay, so if you have read the module, you'll know that we're talking about number patterns, patterns in numbers. Okay, so today we're going to look at figurate numbers. Figurate numbers are another group of sequences that have regular patterns. Okay, uh, if any number can be arranged as a regular polygon using dots, then we can call it a figurate number. Figurate means it's based on figure. If you can write the number or represent the number in a form of a figure, okay, a drawing, then you can call it, and you can see a sequence in those numbers, then we call it figurate numbers. Okay, figurate numbers may also be called, or is there's another name for figurate numbers is polygonal numbers, based on polygons. So we have polygonal numbers. Okay. Okay. So there are three types of figurate numbers that we are going to look at today. The first is triangular numbers, square numbers, and pentagonal numbers. Okay. So we are looking at these three figurate numbers. We're going to look at the characteristics of these numbers and how to derive the formulas for each pattern. Okay. Today we're not doing Fibonacci. Fibonacci we'll do next week. So when you do the tutorial later, you only answer question 1, 2, 3 enough. Okay. Question 4 don't have to do now. Okay. So let's look at the first type of numbers, triangular numbers. Okay. So triangular numbers, they start with 1. This is the sequence for triangular numbers. 1, 3, 6, 10, 15, 21, 28, and so on. So as you see, we can represent them as figures. Okay. Triangular pattern figures. Okay. So this is 1, 3, 6, 10, 15, 21, and so on. Okay. So we see that the first number in the triangular sequence is 1. And then the second number, all these triangular numbers, we can also represent them as Tn. Okay. So the first term, this is T1. Term 2 is 3. So in term 2, we see that we have added one new row here. This is known as nomon. Nomon means the part of the figure that we add on. That's called nomon. Okay. Okay. So for the third term, T3 is 6. Here we have added another row of numbers. For T4, we add another row of numbers. T5, we add another row of numbers. T6, we add. So each time we move to the next term, we add one row of numbers. Okay, so this is term 4, term 5, term 6. If you look at the diagram on the right hand side here, we can see how we are adding each new row for each term. We keep adding a new row for each term. Okay, so in term 2, we add a row of 2 dots. In term 3, we add a row of 3 dots. Term 4, we add a row of 4 dots. Term 5, we are adding a row of 5 dots, and so on. Okay. So the next number in the sequence is another extra row of dots according to the term. Okay. So we have seen here term 6. Term 7 will be, we should add another row of 7 dots, correct? So the nomon here is we keep on adding, okay, another row of dots according to the number of terms, okay? Okay, so we can see that this is actually 1. This is also 1 plus 2. Term 3 is 1 plus 2 plus 3. Term 4 is 1 plus 2 plus 3 plus 4. Term 5 is 1 plus 2 plus 3 plus 4 plus 5. 1 plus 2 plus 3 plus 4 plus 5 plus 6, and so on. Okay, so that is the sequence, in the natural sequence in this triangular numbers. Okay. Okay. If you notice that there is a pattern in these triangular numbers, 1, 3, 6, 10. Okay, there is a pattern. Okay, what's the pattern that we see here? The sum of two consecutive triangular numbers always result in a square number. Okay, when you add these two, you get 4, which is a square number. 2 squared is 4. Okay, when you add 3 and 6, you get 9, which is a square number. When you add 6 and 10, you get 16, which is a squared number. 10 and 15 is 25, which is a squared number. 15 and 21 is 36, which is a squared number. So we see a pattern here. Okay. So we see a pattern here in triangular numbers, that the sum of two consecutive triangular numbers always result in a square number. Okay. Now, how do we derive the formula for triangular numbers? Say, how many dots are there in the 60th triangle? How do we find that out? Okay. So you want to know how many dots are there in the 60th triangle. How do we know this? How can we find this answer? Okay, for this, we need to know the formula for triangular numbers. Okay, so how can we find the formula for triangular numbers? Okay, so this is given here. Okay, term 1 is 1. Okay, term 1 is 1, which means it's also equals to 1 times 1 plus 1 divided by 2. So this is 2 over 2 is 1. Term 2, you know term 2 is 1 plus 3, which is 3. So 3 can also be written as 2 multiplied by 2 plus 1 over 2. Term 3 is 1 plus 2 plus 3, which is 6. And 6 can be written as 3 multiplied by 3 plus 1 divided by 2. So we have term 3, we have multiplied by 3 and 3 plus 1. Term 4, we have multiplied by 4, 4 plus 1 over 2. Term 5 is multiplied by 5, 5 plus 1 over 2. Term 6 is multiplied by 6, 6 plus 1 over 2. So what is term n? Okay, so term n will be multiplied by n plus 1 over 2. So for triangular numbers, the formula is n into n plus 1 over 2. Okay, this is the formula for triangular numbers. Okay, so some people can derive this formula directly from this. Okay, they can look at the numbers and they can write down this, the way of writing it. Like 6, you can write it as 3 times 3 plus 1 over 2. Okay, some of us cannot see this very clearly. Okay, so then maybe there is another way for us to derive these formulas. Okay. Give me a minute. Okay, so we look at these triangular numbers here. This is the first number here, okay? So, so for term 1, okay? So we know that this is term 1, okay? Term 1. So if I added another dot here, okay? If I added another dot here, so this is, this, say, let's say, look, if I add another dot, it's like a rectangle here, okay? Visualize this as a rectangle. So this side here is n, and this side is n plus 1, correct? Is that correct?
Yes.
Okay, so for the second one, term 2, if I add one more dot for each side, one here, sorry, one only one side, I'm adding here one dot, okay? So this side is still n. N is 2, term 2. So n is 2. On this side, it's still n plus 1. It's 2 plus 1. For term 3, if I add one more dot here, okay? If I add one more dot here, then I have to add here. I want to make this a rectangle, okay? So what do I get? So this side is still n. N is 3 now. Term 3, n is 3. On this side is still n plus 1. 3 plus 1. Term 4, if I add another dot, okay, I want to add until I can complete the rectangles, okay? So I have 4 and 5. One side I have 4 dots, the other side I have 5 dots. This is term 4. Term 4 means I should have 4 dots. So this is n. N is 4. On this side I have n plus 1. Okay. I have 5 dots, which is more than 4. Okay. Term 5, I add one more dot here and I'm going to complete it. Okay. Okay, so this side is n, this side is n plus 1. 1 is the red dot, okay? So now I've made all this into rectangles, okay? So this is just to prove the formula, okay? So what is the number of dots in each rectangle? Let's see, okay? So what is the number of dots in rectangle? So here for term 1, we have, so term 1, we have 1. Let's look at the
One dot.
area of the rectangle. So we have 1 into 1 plus 1, correct? N is 1 here. So 1 into 1 plus 1. Okay. Term 2, we have n is 2. So 2 into 2
2
plus
plus
1,
1.
correct? Term 3 is 3 into 3 plus 1. Term 4 is 4 into 4 plus 1. Term 5 is 5 into 5 plus 1. Am I right so far? What is term
Yes.
n? How many dots will there be in term n? Can you understand so far?
Yes.
For term 1, n is actually equals to 1. N is equals to 1. Or this also equals to 1 into 1 plus 1. Term 2, here is 2 plus 1. And here is 2. Okay. So term n will be term 1, 1 into 1 plus 1. Term 2, 2 into 2 plus 1. Term 3, 3 into 3 plus 1. Term 4, 4 into 4 plus 1. Term n,
N
Tn.
into
N into,
n plus 1.
yes, good. N into n plus 1. Okay. So now let's look at the number of dots. This is number of dots in rectangle. Now let's look at the number of dots in the triangle. Okay. In this triangle here, what is the number of dots? Okay, we want to know the number of dots. So,
Divide 2.
yes, 1 plus 1 divided by 2. 2 into 2 plus 1 divided by 2. 3 into 3 plus 1 divided by 2. 4 into 4 plus 1 divided by 2. 5 into 5 plus 1 divided by 2. Therefore, for in the nth term, there will be n into n plus 1 divided by 2. That is the number of dots in the triangle. That from here, we have proved that term n has n into n plus 1 over 2 number of dots, or you can find the nth term by using this formula. So back to our question just now, we wanted to know how many dots are there in the 60th triangle. So we use the formula Tn into n times n plus 1 over 2. So now our n is 60. We want to know how many dots are there in the 60th triangle. So T60 is 60 into 60 plus 1 over 2. How much is this?
108,030.
1,000, one again? 1830, correct?
Yes.
Okay, so that's the answer. So do you understand how the formula is derived here? Ken?
Yes, madam.
Yes,
Okay,
madam.
good. Okay, good. So that is triangular numbers, okay? Okay, triangular numbers, okay, they form equilateral triangles. Equilateral means all the sides are similar, okay? So you can do triangular numbers like how we did just now, like this, okay? Equilateral triangle like this, or you can show them like this, okay? Like pyramids like this. So you must be able to see them in all different ways, okay? So some people use this kind of drawing, some people use like the drawing just now, okay? So if you have a drawing like this is like 1, okay? Then you add one row of 2, and then you add one row of 3, you add one row of 4, you add one row of 5, okay? And you add one row of 6 and so on. It's the same like the earlier drawing, okay? So this is just to let you know that triangular numbers, they don't always have to look like this. They can look any other way. If you notice, they are equilateral triangles because in this side there are 6. On this side there are 6, and on this side also there are 6 dots. That's why they are known as equilateral triangles. Okay, so triangular numbers, they form the sequence 1, 3, 6, 10, 15, 21, and so on, and they follow the formula n into n plus 1 divided by 2. Okay, so next we're going to look at the next figurate numbers are square numbers. Okay, square numbers are just like this. They form perfect squares like this, okay, which means the number of dots in each side are the same. Here's 2, here's 2, okay, here's 3, here's 3, and so on. Okay, a square number, also called a perfect square, okay, is a figurate number where the nth term is actually, from here we don't have to really derive the formula, okay, we already know here. We know that the first term is, what is the first term is 1. 1 is actually 1 squared, okay. Second term is 2 squared, which is 4. Third term is 3 squared, which is 9. Fourth term 4 squared, 16, and so on, okay. So therefore the nth term will be n squared, okay. So for square numbers, the terms are quite easily derived. So if you want to find the 60th term for these square numbers, all you have to do is 60 square. Okay, so this is the 60th term for square numbers. Okay, if you notice, um, okay, um, do you notice a pattern? These are triangular numbers, okay? These are triangular numbers and these are square numbers. Square numbers we represent with the alphabet S, and triangular numbers with the alphabet T. Is there a pattern that you can see? If you look at triangular numbers and square numbers, is there a pattern that you can see here? So um, how do we get the subsequent square numbers here? So this is the first number, 1, and then we add this part here to form the second number, okay? And then we add this to form the third number. We keep adding this, okay? This part is known as the Norman, okay? Okay, there is a relationship. If you look at both the triangular numbers and the square numbers, you can see that there is a relationship here, okay? Can you see the relationship? When you add these two numbers, you get the square number. When you add the next two numbers here, you get this number, okay? When you add these two numbers, you get this, okay? When you add these two numbers, you get this, correct? Is that right?
Yes.
Yes.
Okay, so that means the nth square number is equivalent to, is also equivalent to the nth triangular number plus the n minus 1 triangular number. Is that right? The nth square number is the nth triangular number plus the nth minus 1 triangular number. So supposing you want the fifth square number. Fifth square number, you already know it's 25. Fifth square number is actually 25. So fifth square number is the fifth triangular number plus the fourth triangular number. So the fifth triangular number is 15 plus the fourth triangular number is 10, which is 25. Okay, so numbers have relationships. We must be able to see the relationships in the pattern. Okay, so this is one relationship between the triangular numbers and the square numbers. Okay, so far? Okay, so that's all for square numbers. Square numbers is quite easy, okay? Okay, so now we're going on to pentagonal numbers, okay? Okay, pentagonal numbers. Pentagonal numbers, they begin with 1, 1, 5, 12, 22, and so on. These are the sequence for pentagonal numbers, okay? And if you were to represent them in dots, they would look like this, 1, okay? This is the term 1. So this is pentagonal numbers, okay? P1, okay? P2, P3, and P4. So P1, and then for P2, we have added this section here, P2, okay? And then for P3, we have added this gnomon, okay? And then for the next one, we add this one, okay? So we keep adding until, as we add the numbers, the dots, and the shape becomes, the shape grows and the number also grows, okay? So another way to look at pentagonal numbers is like this, first pentagon, and then it becomes the second pentagon, and the pentagon keeps growing as you add the number of gnomons, okay? So this is another way of looking at pentagonal numbers, or you can look at it like this, okay? This is the first one here, okay? P1 here, one dot, and then you add these 4 dots to make it the second term. Third term, we add another set of gnomons here. This becomes the P3. So this is a new pentagon here, okay? A new pentagon here, and so on, okay? So this is how we can look at it this way, right? So there are many ways of looking at these numbers, okay? Okay, how do we derive the formula? We know that term 1 is 1, term 2 is 5, term 3 is 12, term 4 is 22, and so term n will be n into 3n minus 1 over 2. This is term n for pentagonal numbers. That means if we want to check out term 3, so we just have to represent this with n as 3. 3 into 3 times 3 minus 1 over 2. Okay, this is 9 minus 1, 7 times 3. 8, 8 times 3, 24 divided by 2 is 12. Okay, so this is the formula. But how do we get this formula? Okay, so it is not easy to derive this formula just from the sequence. Just looking at the sequence, I don't know if we can derive this formula. Okay, okay. So let's see how we can derive this formula. Okay. Okay. So this is the first method that we are going to use to derive the formulas for pentagonal numbers. Okay. So before we derive the formulas, let us look at the relationship between triangular numbers and pentagonal numbers. Okay. These are triangular numbers and these are pentagonal numbers. Okay. If the first numbers are 1, both of them have 1 as the first number. Okay. But there are other relationships that we can see here. So for pentagonal number, the second number is 5. Okay, how is 5 related to triangular numbers? We know that 5 is 3 plus 2. Okay, so we know there's a 3 here. We need 2 more. How do we get the 2? If we times this by 2, so we have 2 plus 3 gives us 5. 12, how do we get 12 from triangular numbers? We know that 12 is 6 plus 6. So we already have 1 6 here. How do we get 6 from this? If we times this by 2, we can get another 6. So can you see the relationship here? Yes? So what is pentagonal number 4, term 4? It is the same as, can you give me a relationship here? P4 is T.
Pn
Okay, if I use a number here, what will it be?
T3
T, what is that?
T3 times 2
3T, okay, yes, T3 times 2, but T3 times 2 is what? 6 times 2 is 12. I want 22, so I still don't get 22. So how?
plus T4
Yes, plus T4, okay? It is T3 times 2 plus T4. This is the relationship. That means there are 2 triangular numbers here plus another, there are 2 of n minus 1. Okay. Or in other words, we can write this as Pn is equals to Tn minus 1 times 2 plus Tn. Okay. Okay, why is that true? Okay, we're going to see in drawings and in figures how we're going to visualize why this formula is true. Okay, okay. You look at the first drawing here. The first drawing here. Okay, so this is term. What term is this? P. If there are 3 dots in the side, that means it's P3, term 3. If there are 4 dots in each side, it is term 4. If there are 5 dots, then it's P5 or term 5. Okay. So for P3, term 3, we have this figure here. And this figure, we can divide it into triangles. Okay. We have divided it into 3 triangles. The purple triangle is term 3 because it has 3 dots on each side. It's a equilateral triangle with 3 dots on each side. 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is T3. The green triangles, they are T2, term 2, because there are only 2 dots on each side. Correct? So pentagonal number 3 is equivalent to T3 plus 2 of T2. Correct? So pentagonal number 4 is equivalent to, this is T, the purple one is T,
Before.
T4, yes, T4 plus the green is T, 1, 2, 3 dots each side. So this is T3, this is T3, this is T4. So we have 2 of T3. Pentagon number 5 is equivalent to, the purple is T, 1, 2, 3, 4, 5 dots, so it's T5. Green is, there are 4 dots on each side, so this is T4. This is also T4, so we have T5 plus 2 of T4. Okay, so this is the relationship between pentagonal numbers and triangular numbers. Okay, so let's just, so we can see that each pentagonal number is the sum of 3 triangular numbers. Okay, so that's a very important relationship that we should know. Okay, each pentagonal number is a sum of 3 triangular numbers. Okay, so this one P3, oops. Okay, so P3 is T3 plus 2 T2. But what is T3? We know that T3, the formula for triangular numbers is n into n plus 1 divided by 2. So T3 is 3 into 3 plus 1 over 2, which is 6. And T2 is 2 into 2 plus 1 over 2, which is 3. Okay, so P3 is 6 plus 2 times 3 is 6, which is 12. Okay, for P4, this is P3, yeah? So P4 is actually equivalent to 3 T4 plus 2 T3. And we know that T4 is 4 into 4 plus 1 over 2. 4 plus, how much is this? 10, correct? And T3 is 3 into 3 plus 1 over 2. This is how much? 6, correct?
Yes.
So P4 is equal to 10 plus 2 times 6, which is 22. Okay, so P5 is
24.
T5 plus 2 T4. So T5 is 5 into 5 plus 1 over 2. How much is that? 5 plus 1 is 6. 6 divided by 2 is 3 times 5, 15. Okay, and then we have T4, which is 4 into 4 plus 1 over 2, which is 10. So our P5 is P5, I'm going to substitute straight away. Yeah? P5 is 15 plus 2 times 10, which is 35. Okay. Okay. So now that you have seen this, let's derive the formula for the nth. We've already derived it. We want to write down the formula for the nth pentagonal. Okay. Therefore, the nth pentagonal number is equivalent to the nth triangular number plus the n minus 1 triangular number times 2, correct? So what is the nth triangular number? What is the formula? N into n plus 1 over 2 plus the nth minus 1 triangular number is we substitute n for n minus 1. So it is n minus 1 n minus 1. We're substituting n minus 1 into here, okay? And substitute n for n minus 1 plus 1 over 2. This whole thing we want to times by 2. Correct? Yes? So this 2, we cancel it off. So what do we have? How do we solve this? So we have 2n, let's open the bracket, n squared plus n plus, what do we have here? N minus 1 plus 1 is 0 already, so it's n, okay? So 2 divided by 1 is 2. This will be 2n squared minus 2n. Am I right? Yes?
Yes.
Okay, I've missed a few steps here, okay? So if you do step by step, you will find that it's correct, okay? Okay, so simplify this, what do I get? N squared plus 2n squared, 3n squared, n minus 2n is minus n over 2. Simplify it some more, okay? We can factorize it, take out the n, okay? So we have n into 3n minus 1 over 2. This is the formula that we got just now also, okay? So this is how we got our nth pentagonal number, okay? It is not, we don't just memorize the formula. We need to know how to derive the formula, okay? So to derive the formula, we need to see the relationship between triangular numbers and pentagonal numbers. And then from here, we work out the formula. We will come out with this formula. So this is very important, okay? So you need to know exactly how to derive the formula. So is this okay? Everybody understand this?
Yes.
Any questions you want to ask? Okay, then let me show you another method of deriving the formula for pentagonal numbers, okay? So here we want to derive the formula for pentagonal numbers again. So what number is this? The first row here, what type of numbers are these?
Triangular.
Yeah, these are triangular numbers. Second row,
Square.
squared. And third
Square.
row is pentagonal numbers, okay? So is there a relationship here between triangular numbers and pentagonal numbers? Can you see any relationships between, from the pentagonal number, can you see any relationship between triangular and square numbers? How do we get 5 from triangular and, because the first term is all 1, it's difficult for us to predict anything. So let's look at the second term, okay? So for the second term, for pentagonal numbers, we have 5. How do we get 5 from triangular and square numbers? Do you see any patterns there? What is 5? 5 is 2 plus 3, 1 plus 4. So do you see any patterns? Yes, isn't it? You can see a pattern here, right? Yes? 1 plus 4 is 5. So the next one will be 3 plus 9 is 12. 6 plus 16 is 22. 10 plus 25 is 35. So P5, P2, second term for pentagonal numbers is the same as, is equals to S2 plus
T1.
yes, T1, correct. So if I write it generally, Pn is equals to S
And
n minus 1.
yes, plus T n minus 1. Okay, good. So that means these pentagonal numbers consist of square numbers plus triangular numbers. Okay, so if you want to look at it visually, this is what it will look like. Okay, so P1, the first number is 1 square plus no triangular numbers. P2 is we have the second square number plus the first triangular number. P3 is third square number plus second triangular number. So this is S3 plus T2. This is S2 plus T1. This is S4. How do we know 4 or 3 or 2? We look at the number of dots on each side. Here is 4, so it's S4. For triangular numbers, the number of dots is 3, so this is T3. So this is S5 plus T4. S5 plus T4. Okay, so this is S6 plus T5. Okay, so from here we know that Pn is Sn plus Tn minus 1. Okay, so let's write out the formula here. So we know Pn is Sn plus Tn minus 1. Okay, we know that Sn is n squared. This is the formula for square numbers. Okay, and the formula for triangular numbers is n into n plus 1 over 2. Okay, so therefore the formula for t n minus 1 is substitute n for n minus 1. That means we have n minus 1 into n minus 1 plus 1 over 2. Okay, this is equivalent to minus 1 plus 1 is equals to 0. So this is n into n minus 1 over 2. Okay, so from here, Pn is equals to substitute our Sn is n squared plus Tn minus 1 is n into n minus 1 over 2. So now we want to simplify this. So we have the 2 here, okay? So we're going to find LCM of 2. This is 2n squared plus n into n minus 1. Okay, so this is also equivalent to, let me open the bracket first. Okay, 2n squared plus n squared minus n over 2. Okay, so this is 3n squared minus n over 2. Factorize it, take out n, you have 3n minus 1 over 2. Same formula as just now. Okay, just that now we use the relationship between square numbers and triangular numbers to derive the formula for pentagonal numbers. Okay, earlier method we used the relationship between pentagonal numbers and triangular numbers only to derive the formula. Okay, can be done? Yes, so whenever you are given numbers like this, you must be able to see relationships. There are a lot of relationships that you can say. You can say that all numbers, all three figurate numbers start from 1. That's also a relationship between numbers. Okay.